Ready. I wanted to make sure that you all had uh, the uh, the review of this section for the fundamentals in microbiology, that you are able to access this recording so that we can go through all of the information that is accessible, and that you have a chance to answer. I have a chance to answer questions that you gave to me during this week. Thank you for the additional questions I got. I will send you a link. You should have received a link to this, and you should be able to view this recording. Um, I first, I just wanted to mention that I know I have received a couple of people have asked me about adjusting the time for both the practical and the written exams this weekend. The written exam is open as our typical Saturday at midnight through Sunday night, so 48-hour period. The practical exam was for Thursday and Friday. I'm going to go ahead and extend that into Saturday, so it will be 72 hours. You will have the opportunity to take the practical exam, and then the following will be the written exam. Okay. The practical exam is set up in eight case studies each, and the way this was intended was to initially, when we first started doing practical exams, was to do this as if you were in person. So each set, each case study is based on as if you were looking at a culture. Okay, so you have, instead of having the plates in hand, you will have images of plates, and each one will represent a different kind of culture. It could be throat culture, it could be stool culture, sputum culture, urine culture, wound culture, whatnot. Okay. And you are going to be ultimately asked what you think the organism identification is and why. Supporting your answer is always going to be just as important as the actual identification. So you will have a series of plates to look at, and for each case, and you need to take a look and describe each of the organisms on each of the different kinds of media. And so how I would approach this, each one of these, since they are, each case is representing a different kind of culture, I would approach it as if you are um, reading the plates yourself. So you want to think about what are the pathogens of this particular type of culture. Okay. So, and then what are the plates that need to be set up on these cultures in order to actually grow the pathogens that we're looking for. So that means you actually need to have an understanding of what the pathogens are for the different sources. What are the pathogens that we are looking for in sputum culture? What are the pathogens we are looking for in the urine culture? Okay. What are the pathogens we are looking for in a throat culture? Once you have that understanding, well, what are the plates, the pieces of media we need to set up in order to capture those pathogens? Then you need to be able to think about, okay, on the different pieces of media, what would those organisms look like? If it is a throat culture, well, what's the pathogen, the primary pathogen of throat culture? I think we all should be able to, without doing too much thinking about it, should be thinking of group A beta streptococcus, or the other name would be Streptococcus pyogenes. Okay. Well, what does that look like on the plates? What media are we looking at? We should be looking at a blood agar plate. Well, what should it look like on the blood agar plate? Well, Streptococcus pyogenes is a beta hemolytic strep. So we are looking for beta hemolysis. Okay. What other tests might I use to confirm my suspicion or rule out another type of organism? So then you need to be thinking about, okay, well, are there other tests that I can use? Was there a bacitracin disc dropped? What does that look like? If there's no bacitracin disc, well, what other tests could I run to confirm my suspicions? So you should be thinking, okay, group A beta strep. If I don't have a bacitracin disc, what about the PYR disc? Okay, so there, or what about latex agglutination? Okay, so that's sort of the process you should be thinking of. So how I would start is looking at the pathogens for each of the different types of sources that we have discussed. And this is going to be part of your review anyway, even for the written test, okay? So, but specifically for these case studies, you want to be able to distinguish the pathogens out of the different types of sources that are being presented, okay? And then the process of, well, how would I further identify this organism or rule it out? And I should be able to always support my suspicions, okay? So, and then we're going to discuss some of this additionally in this review. So that's kind of how I would approach the practical, okay? It's like I said, there's 8 case studies, and each case study is a different type of culture or a different culture, okay? Additionally, on the written exam, it's 100 points, okay? And I believe the last 20 points are also in a form of case study type of questions, okay? That means that I think there's about 50 questions that are not case studies. So they're going to be multiple choice, maybe a short answer, true and false, matching, things like that. And then there will be the last section are also case studies, but just you're not going to have images. So they're going to be more based on information that you received, maybe with patient history involved. So when you have those kind of case studies, it might be a little bit different. So you don't have the plates in front of you. You might get descriptions of the plates, but it might be much more in depth into the actual patient history. So that you're going to equally need to be referring to, well, what do I know about wound cultures, perhaps? What kind of background might I be looking at? Patient that has, for instance, as an IV drug user, and we have a Staph aureus mixed with another organism that is an emerging pathogen, and typically the gram stain would be a gram-positive bacilli, typically seen in the respiratory, causing a respiratory pathogen. In this case, it's a wound pathogen. Okay, I might give you more information based on the gram stain, and then you would, and as you get to the point where you might say, okay, this looks like maybe cutaneous diphtheria, and you need to further identify what are the other tests that might be helpful, okay? I'm making this part up, okay? I'm just telling you, these are the types of questions that might be included, okay? So it's a lot, okay? It's a lot of questions. I think it might be too much to take both on the same day. If that's the only option you have, then go ahead. I will go ahead and open up that virtual practical on Saturday as well. But I think, honestly, I think that's a little much. But that's up to you. I know that not everyone has the option to take them on 2 different days. All right. Okay. That being said, I'm going to kind of go through some of the questions that you presented to me that you wanted me to cover. Okay. Okay. I'm just going to tell you some, based on kind of what I've already mentioned about how I would approach the practical exam. These are some things I would review as you're kind of going through the material. Always start with the objectives on each of the units. If you feel successful at those objectives, you'll do fine. Okay. If there's one of those objectives you really feel like you need review, then hammer that section. If there's something in the objective you feel like we didn't cover, send me an email. I'll try to get back to you, but you need to send that pretty quickly because towards the end of the week, I will be harder to get in touch with. And by the weekend, will be too late. So take a look at those objectives, and if there's any questions about those, get back to me and I will try to find that information for you, okay? But I would start with just kind of looking at the different gram stains, making sure you understand that process, knowing what the major pathogens are in each of the gram-stained organisms, such as gram-positive cocci, gram-negative bacilli, your staphylococcus versus your streptococcus, okay? Go through the flow charts for your gram-positive cocci. I sent you some copies of those, and those should be helpful to you based on those basic biochemicals, okay? So for instance, gram-positive cocci, you should immediately be able to decide what's the first test that I need to run on if I have a GPC. That should be a catalase should be your first test. That should tell you whether you're dealing with a staph or a strep. If it's catalase positive, okay, then your next step should be a coagulase. Coagulase positive, Staph aureus, coagulase negative, coag negative staph. Decide whether you need to further identify that based on the source. Urine cultures, you definitely want to make sure you can rule out Staph saprophyticus, okay? So that's sort of how you sort of decide how do you go through that flow chart. Streptococci, the same thing. You typically are going to start, your catalase should be negative. Take a look at your hemolysis, decide how you want to process, go through based on the hemolysis of the organism, okay? Also, take a look at the different pieces of media that we discussed. That was in the earlier part of specimen processing. But again, if you understand all of the different types of media we discussed, that will help you when you were doing both your practical and your written, because you're going to you need to know and understand why we're using different pieces of media. So review that up front so that when you come to how we're actually setting up different cultures and what we're looking for, you've already reviewed the basic pieces of media and what they're used for, okay? Okay. I would suggest going back to one of the earlier units that you briefly familiarize yourself with the best practice for specimen collection based on what type of culture you want you're testing. So if it's an anaerobic culture, what are the best types of specimens for that? Are there any specimens that are not acceptable for anaerobic culture? If you have a genital culture, what's the best type of specimen for those? Okay. Once again, same thing with each type of specimen. Throat culture, sputum culture. How do you evaluate the quality of its sputum culture? Okay. What are you looking for in the gram stain? What represents poor quality versus good quality? Okay. So I'm just going through this list, making sure that I'm covering things that people have asked me for. Okay, let's talk a little bit about the primary pathogens for different specimen sources. So we already talked about throat cultures. Okay, what about urine cultures? Remember that most urine cultures that are positive, that represent urinary tract infections, are the organisms are coming through an ascending route. So you're typically getting organisms that come from the fecal flora that end up causing UTIs. So that's Enterobacteriaceae, Enterococcus. So any of the organisms that are normal flora in the gastrointestinal tract. Okay, those are the most common causes of UTI. Okay. Additionally, if patients have other kinds of infections that the UTI may be coming from a different source, then you might be looking at things like Pseudomonas, Staph aureus, some of the beta streps, yeast, things like that. Okay, so think about, well, if that's my pathogens. Most of my pathogens are Enterobacteriaceae. What are the pieces of media that are going to be most helpful to identify those? So for urines, primarily, we use a blood agar plate and a McConkey. Okay. what are those pathogens? What are they going to look like on those plates? Okay. If you have an E. coli, what's that look like on the blood plate? What's that look like on the McConkey plate? Okay. So that's sort of the process you should be thinking about as you're going through and thinking about primary pathogens. Additionally, with urine cultures, you are thinking about not just the organism itself, but also the quantity. Okay. I'm going to share with you, find this. As soon as I find this file. There we go. Okay. Now this is specifically used by the lab that I work for. Okay. So trying to zoom in here a little bit for you. Not sure I can zoom in here. I'm hoping you can actually see this well enough. Now, just so you know, these were all set up using a 10 microliter loop. Remember, when you're quantitating a urine culture, you have to understand what the the volume of the quantitative loop is before you can actually quantify the urine. So in this case, these were all set up with 10 microliter loops. That means each colony on the plate is representing 100 colony forming units per mil. If you were to use a 1 microliter loop, each colony would be equal to 1,000 colony forming units per mil. Okay, so it's important. That's quite a bit of difference. So you have to have a good you really have to know what the quantity, what the loop is, the inoculation volume is before you can quantitate. Okay. So for instance, in this first image on the left, this is a Staph aureus. There's these are all different volumes, different quantities of the same organism type. So on the plate to the left, there's 5 colonies growing on this plate. So times 100, this would be 500 colony forming units per mil. Typically, that would not be a significant colony count. Okay? Now, if I told you this was a 1 microliter loop, now that would be 5,000 colony forming units per mil. Okay, that's still not a significant amount for a clean catch of non-sterile urine. The plate next to it that's in the middle, that middle plate, that has 58 colonies are on this plate. Using a 10 microliter loop, our quantitation is 5,800 CFU per mil. Still not significant if it's a non-sterile urine. However, if that was a 1 microliter loop, now that is 58,000 CFU per mil. Okay? That represents a possible, not definitive, but 58,000 is in a threshold that you would want to further work up and probably report. Okay. So it all depends on what that initial volume is. Okay. Then of course, if you could look all the way to the right, there's this has approximately 580 colonies. So now that's going to be significant no matter what the volume is. If it's a 10 microliter loop, it's 58,000 CFU per mil. If it's a 1 microliter loop, it's 580,000 CFU per mil. Okay? So each one of these is representing a different quantity. Okay. Okay.